Okay, so welcome back. Now, here's what I have. Forgive my drawing, it's pretty crude. But here's the next thing. So now we have an ellipse, and we have an inscribed rectangle inside the ellipse. So we have an ellipse with an inscribed rectangle. So the question then becomes, how big of a rectangle can we inscribe in there to maximize a particular variable or value? Okay, so let's read and then we'll jump right in. It says a rectangle is to be inscribed in the ellipse x squared over 4 plus y squared equals 1. So here it is. Here's the equation of the ellipse. Okay. And so again, here's my crude drawing, and we want to inscribe a rectangle inside it. It says, what should the dimensions of the rectangle be to maximize area? So we want to maximize the area of the rectangle. Now notice that xy, right, represents a point on the ellipse. Now depending on where this point is, will determine the rectangle, because this distance and this distance must be the same, because it's symmetric. And this, obviously, depending on where this distance is, this distance has to be symmetric across the y-axis. And so we can describe the rectangle by just using this one point in the first quadrant, because if it's here, then we're going to have just a straight line. We won't have a rectangle. If the point is here, then again, we're just going to have a straight line this way with no rectangle. So we can say that x is going to be anywhere from 0 to 2. Okay? And if x is from 0 to 2, we know y is going to be from 0 to 1. Okay? So x is from 0 to 2. Okay? And again, y is greater than 0, right? So now, if we solve this for y, we get y equals the square root of 1 minus x squared over 4. Okay, and so that's the equation that represents y. Now, we also need to come up with the area formula. Well, in this case, now notice, I'm going to do everything in terms of what? What is the area of this rectangle? Well, if I'm using xy as a coordinate, well, that means that this distance here is x. So the length of the rectangle is going to be 2 times x. The distance here for the point is y, so the distance of the width of the rectangle is going to be 2 times y. So the area of the rectangle will end up becoming 2x times 2y, or 4 times xy, right? Okay, so far so good. Okay, and that's just using the formula length times width. Okay, now we're going to substitute, because now that we know y is equal to this, we're going to substitute in, and so our area formula then becomes 4x times the square root of 1 minus x squared over 4. Okay. So now, we've got our domain. So again, it must satisfy. Now, here's the thing. If x is equal to 0 or x is equal to 2, we don't have a rectangle. So our area would be 0. Okay? but we're going to consider the closed interval from 0 to 2 so we can find the maximum, the absolute maximum, because again, remember, this is continuous, and it's continuous over the bounded closed interval, which means there's an absolute maximum and an absolute minimum, so we're going to check the critical values and the endpoints, just like we did before. So now, and we know that the absolute maximum occurs at an interior point and if we find that, then we know we have a maximum of the open interval. Okay. So that's it. So let's figure this out. So we've got to let's see. Let's write this as an exponent. Okay? And we know that the area at the endpoints is going to be 0, so we already discussed that. So if x is inside the interval 0, in the open interval 0 to 2, then we know that the area is going to be positive, right? So that's obvious. Okay, so now what we're going to do is we're going to find the derivative. Okay, so again, you could use the product rule, but again, you just follow along. There's more than one way to do this. So I'm going to use the product rule. So this is going to be the derivative of the first times the second. So I'm going to write 4 times the square root of 1 minus x squared over 4 plus 4x times the derivative of the second, which is going to give us 1/2. Right, so I'm going to use the chain rule, so it's going to be 1/2 of 1 minus x squared over 1 to the negative 1/2, so the square root's going to go in the bottom. So this will be 1 minus, x squared over 4. And then times the derivative of the inside, which is going to give us what? It's going to give us 1/2 x. Okay, now this is going to give us 4 times the square root of 1 minus x squared over 4 plus, now this is going to simplify, so this is going to be 4 times the fourth, which is 1, so this is going to give us x squared over the square root of 1 minus x squared over 4. Okay, so now all I'm going to do is I'm going to get a common denominator, right? So all I'm going to do is multiply the top and the bottom of this by this. So now what happens here is this radical is going to go away. So I'm going to get 4 times 1 minus x squared over 4 plus x squared, right? And then I'm going to have the common denominator of the square root of 1 minus 4. Now I'm going to simplify. So if I distribute this is going to be 4 minus x squared. Then I have plus x squared, which is going to cancel. So I'm going to get, excuse me, I'm going to get 4. Okay, so I'm going to get 4 in the numerator. And I get this in the denominator. Okay, so I get the same thing. So now I end up with 4 divided by the square root of 1 minus x squared over 4. Okay, now, okay, something's not right here. What did I miss? No, that's right. I think, no. Oh, no, that's right. Okay. So now, is this right? Something's 4 minus. Okay, let me go back here, just make sure I didn't make a mistake here. 4xy, 4x times 1 minus x squared over 4 times that, so it'd be the derivative of the first times the second plus the first times the derivative of the second, which gives me 1/2 times that times the derivative of the inside, which is negative. Okay, so this should be negative 1/2. So negative 1/2. Okay, that's fine. Okay, so that'll give me negative -4. Or no. That's fine. This would be minus. Okay, so then this is going to be minus. Okay, so then this becomes 4 minus 2x squared. Oh, okay, that's better. Okay, now that's correct. Okay. So now we want to set this equal to 0. Okay. Now, at this point, what is going to make this equal to 0? Well, the only way to set it equal to 0 is if the numerator is equal to 0. So that would mean that 4 minus 2x squared equals 0. which would mean x squared would have to equal 1/2. Excuse me. Oh, no, not 1/2. 2. Right? Subtract 4 from both sides, and then divide by -2. So now, that means x would have to equal plus or minus the square root of 2. Okay, so now, but here's where we have to, again, make sure that we go back to our domain, because remember, domain is between 0 and 2. Okay? Okay, so the domain is this. Negative square root of 2 is not in the domain. So x equals the positive square root of 2. And so to determine the dimension of the rectangle, we need to determine the length and the width. So if x is square root of 2, right? So if x equals the square root of 2, then the length is equal to 2x, which equals 2 times the square root of 2, right? And since x is the square root of 2, y is equal to this, which would be equal to the square root of 1 minus x squared, which is the square root of 2 squared, which is 2 over 4, which then equals the square root of 1 minus 1/2, which is 1/2. So this would be equal to 1 over the square root of 2. Okay, now, so that means the width would equal 2y, which is going to be 2 times this, 1 over the square root of 2, or 2 divided by the square root of 2. And of course, we would want to rationalize this. So we're going to multiply the top and the bottom by the square root of 2. And so that gives us 2 root 2 over 2, which just equals square root of 2. So now we've got our width and our length right there. And so now, what is the maximum area? Well, now we just multiply. So area equals length times width, which is going to equal 2 root 2 times root 2, which equals 4. So these are the dimensions. So again, to answer the question, what dimensions does it have to have? Well, it has to have a length of 2 root 2, and it has to have a width of root 2, and gives us an area of 4 units squared. Have a great day.